This notation here means the second derivative. Okay, if you see df of dx, I think that came up early in the course, this is the rate of change of the function f with respect to the variable x. So it's telling us how fast the y values are changing for one increase in the x variable, you could say. Okay, this is derivative notation. It's another way of saying this. Okay, so this is second derivative notation. So what we need to do is we need to first find the first derivative. So we have to use, at this point in the course, we have to use the limit definition of the derivative. So that means we need to find f of x plus h. When we use the limit definition of the derivative before, a lot of the time we were finding the slope at an instant. This question is asking us to find the slope of all the function, of all f of x. So we have to keep, instead of using like 1 for our location, we have to keep x in there because it's for all values. And we subtract that by f of x and divide it by h. So f of x plus h means we're supposed to plug in x plus h everywhere where we see an x in this function. And then, okay, so all I've done so far is I've written this out. And I need to subtract it by f of x. And then divide it by h. Okay, so now it's a bunch of algebra. I have a divide by 0 problem if I was to just plug in my limit right now. So I've got to simplify somehow. And distributing this, I just did in another video, so this is why I'm going to be able to do it so quick. But you'd need to do x plus h times x plus h, and then distribute the negative 3. I think I got that right. And then here, that one's a lot easier. Distribute the negative sign. Divide the whole thing by h. And now let's see what we can simplify. We should only have terms that involve h now for the magic of this instantaneous rate of change notation to work out. Look, start with the highest power. Negative 3x squared and 3x squared cancel. 3x and negative 3x, negative 7 and 7 cancel. Now we're just left with negative 6xh minus 3h squared plus 3h. Everything's being divided by h. So you can divide each term by h. So that means this is gone. Oh, sorry, just one power is gone here, and this is gone. Every term gets divided by h. Now do we have a divide by 0 problem? You can plug in 0 in for h, and that means this is going to be gone. So you're just left with negative 6x plus 3. That is the first derivative, okay? We just found out that the first derivative, or in other words, using the notation that we're using right now, the derivative of f with respect to x is negative 6x plus 3. Okay, but we got to go back to the drawing board because we're supposed to find the second derivative. We just found f prime of x is negative 6x plus 3. To find the second derivative, we've got to use the limit definition of a derivative again. So everywhere where we see an x, we're supposed to plug in x plus h. So that's the first part of the limit definition of the derivative formula. I didn't write the whole thing out this time, so just watch out for that. So subtracted by f of x, that's the second part of the numerator. Then divide by h. So we can distribute that negative 6. Combine like terms, so negative 6x cancel, 3 and negative 3 cancel, and negative 6h divided by h, that just makes negative 6. And so the limit as h approaches 0 of negative 6, well, who cares what h approaches? It's not even a variable here. It's just going to be negative 6. Alright, so we just found the second derivative, which is what they wanted. The second derivative is just -6.